Hi all. If you are anybody's there already, I am just trying to get um it in so that I can watch the live feed here. That's why I haven't actually started doing anything yet. Live. View live and control room, that's what I want. I'll just set all these over here. And yeah, I can see you now. Hello everybody. Today I am going to be drinking out of this beer here. It's my own beer, so not someone else's. And we are just gonna work for just an hour here because I have to go for supper right after. But this one's already late. I was wanting to do this probably yesterday. I didn't. So what we're doing, you can see sort of in the corner, I think by me over there, that I have a circuit, two ones I sketched out on my, what's it called, just paper, on the paper there. And it uses this as the counter, and then obviously just this timer. I brought it up so that I could see what the pinout was. And I'm just gonna see how far I can get into making a PCB for it today, because I want to make a PCB out of it. So yeah, let's go. We will fire up KiCAD first, I think. Probably not going to come up though. Yeah. I've had that happen. I don't know. Need to get my system working better here. Let's go here. These projects. No, we don't have to go there. Disruptive tech. Oops. This one. And I'll just open up this. Then we can get it. KiCAD open. That way. Go file. New project. Back here. 4-bit counter. 4-bit counter. Save. It's open. Okay, now let's go. We'll add the 555 first, might as well. Purpose. Timer. Do this one. You can hear my dog is eating stuff on the floor. Okay. So the timing circuit we're going to do first. For that we need two resistors. Now if you look, I'll say R1, the small one. If you look at my calculations in the whatchamacallit place, on the, again, on that little thumbnail that I included, I made this one 10 times, or I made R2 10 times the size of R1 so that I could ignore R1 when estimating how much I wanted the delay to be. So I was aiming for around 5 seconds, just so that you could sort of watch it. And I just estimated instead of actually calculating it exact. I just said, we'll just say that this is much bigger than this one and be done with it. I know, lazy of me. Okay, but we have those two there. Might as well put the values in. 560K. Okay. You are 56K. Okay. Now, let's add capacitor next. I want a polarized capacitor. It is polarized capacitor. We could probably move this up here. Like it's in line there. This I'll just move here. This here. Good. Yeah, this will go down there. So got that in. Let's add some polarized capacitors, or unpolarized capacitors. Hold on. This one. We made one. Control voltage. I'm gonna make this invisible here. Well, I guess we're gonna have to put what did we make it? 4.7 microfarads. I'll make oh, whatever. This one we're just gonna go 0.1 U. And now got that and that. This we'll make one more of these ones. Control B. That's gonna be just the decoupler. For the VCC, just to make sure we get a steady, good voltage power supply. There. There. And let's just start wiring things up here now. This is again just for the timing part of the circuit. Up there. And the trigger goes to, it just seeks out the capacitor voltage, and threshold is connected to the trigger. Control voltage is connected there, and we get another ground in here. Reset, we will tie to VCC. New. New. Wonder why it kept on doing that. Oh, I think I know why. Okay. Let's just go here. Now that's good. It was just connecting it because it was going through the points here because I didn't move it out further. Not sure if you understood that. So Sorry, I could explain it better if anybody didn't understand all my mumblings. Let's connect the discharge pin, which goes in between these two. Might as well lap it right around here. This is looking quite messy. I apologize. I like to try to do these quick is the problem. So it sort of adds some excitement to it for me. I think you're good. We can check it out after. I think that's looking pretty good. Anybody have any questions or comments yet? Ooh, just cracked my back somewhere. This is the output, and it obviously is going to go to our timing circuit. So let's just add, see if we have it. Here's the one I used. 74 HC 163. Nope. What we will do is we're actually going to just make our own, I think. Might as well. We'll go to symbol editor. Open this other screen. Now I am gonna flash up here. Oh, no, I don't have it open on that one. I have it open on this. So I'm just gonna flash this up here. It's the data sheet for the counter we're using. Yeah. I just want to go look. Okay, there it is. So this is the diagram they're saying to use. I am going to new symbol. No symbol library. Where did my one go? I think I made one. Did I call it Cody Custom Run? File. New library. Load. Now we're in custom symbols. We're going to make one symbol name, CD 74 HC 163 D. Just so you know, I can't actually see you right now. So I have the data sheet in my way. But I will look at it later. If you have any questions or comments, just put them in. I need to draw lines. Ah! I haven't done this in a while. Okay. Place pins. Pin name. We will do 1. R. Don't know how to put in the bar there. Whatever. Electrical type. Yeah, it's an input. It sort of, they put it right in the middle here. CP 2. It's also an input. SPE. Forget how you're supposed to represent bars in this way. It's like these all have a bar. The SPE and the MR. You see? Right there. Bar. Forget how you're supposed to do that though. Okay, so let's keep going. Oh wait, I made a mistake already. This is pin 9. Gonna go. Well, I can't use that. Place. Drop pins. Pin name. PE 7. PE 10. Oops. I think I'm gonna move this guy down one. Maybe move all of them down. There's room. Then you, I didn't name it, so it's P0. Yeah. Name. Oh, oops. P1. This is pin 4. Sorry. I am getting a bit muffled here. Let's move this in here. Place more pins. Pin name P2. 5. P3. 6. There. And now we go to the output. So we'll use the shortcut P to add a pin. And we'll go Q0. This is an output. And it's pin 14. Q1. And it's pin 13. Q2. And it is pin 12. Q3. And it is pin 11. Oops. 11. Okay. And PC. So this is the when you count in and it gets full, that one you tie to the next counter so that it will increase the count on the next counter, and then this one goes to 0. In my case, I just tied another one to it, another, what's it called, LED to it, so it'll turn itself on at the end and then keep going. Okay. Now, it didn't include 8 and 16, which happened to be the ground and power pins. Let's add them now. Press P again. Pin name VCC. Number 16. Power input. Right there. And GND 8. It's also, I guess, power input. Okay. Now I'll save that. Let's move it out of the way. Then I'll click the A button, add one, and I'll go 74 HC 163. There it is. Okay. And then there we are. Now we can start with taking this guy over, connecting it to the counter. Now, also gonna have to, let's add connector. Let's just go back here, connector, new. See what we have for connectors. Connector generic. Yeah, let's just use that. Okay. So this is where, because I'm not entirely sure, I'm going to use a battery, but I'm guessing I can just use 2 holes there. We'll see what we decide to use for there. I tested this at 4.5 volts. I figured I'll use 3 AA batteries to power it. The reason why I'm going with so much power is that eventually I'm going to try and use those noodle LEDs and decorate a 3D printed Christmas tree. Here, I'll minimize these so I can see if anybody has any questions yet. No. Okay, so G and D. I'll add another one there. Oops. Okay. Then we will add a VCC. Okay. There. Cancel. Yeah. Let's go Control C and Control V. Then over here we do the same. Over one. this in here. Control C. Control V. There we go. Now, take one of these up here, plop it up here. Because each one of these, actually I just have connected to ground. So I don't want them to be set by anything. And now, go look at my circuit. You can see one in the corner right over there. Or, well, like sort of right beside my head here, I guess, from your perspective. So the PE and the TE, so PE, TE, and SPE all get to VCC. Go there, and then I say PE, TE, the MR also goes there, SPE, there. So they all go to VCC. Now, might as well there, grab. Just delete this part. There we go. I just wanted to move it a bit closer so that they're not so far away. Now we will add more resistors. Guess we can move them apart here. Yeah, if anybody has any questions or just wants to mark where they're from or anything, just do that in the chat. I'll be watching. Always freaking moving stuff there. Good. Okay. Go here. Yes, since we also put one on this one. Ah! That's not what I wanted. Okay, so we got those. Now, we have to add an LED. And go down there. Good. Okay. This is the only one that was moved out of the way. Ooh. You know, a couple days ago, I actually had a weird thing happen. I was went down a Wikipedia rabbit hole and ended up on a page about Japanese spider crabs. Oops. Sorry. Have you ever seen them before? They are giant crustaceans. Very interesting. I didn't know that they existed. Like it was a weird thing to know that that's an actual thing. These big spider crabs. Anyways, I just thought I'd mention that. Maybe to break up some of the monotony of this this certain wire in here. There. Here, I'll actually bring that up. Spider crab. See, look at that thing. It's gigantic. See? Massive. Well, anyways, that's not what we are here to look at. We are here to make this circuit. So I set all these at 220 ohms. Now whether or not that's going to work for what I'm planning, which I can show you in a second here. Nope. I haven't wired this one yet. So we'll save this. Now, what am I looking? Noodle LEDs. Sorry. AliExpress. I'm just looking at the AliExpress ones because this is the ones that I had looked at. So they're 3-volt ones. Sure, they will be fine. We're wondering how I will connect them. They don't really have full positive electrode. Yes, they just say hold positive. Okay. What we will do for their footprints, probably just 2 holes. Side by side. So we need to assign footprints now. Cancel. So here's our footprint assignment tool, showing the 4.7 microfarad on. Let's just do the LEDs first. Um, let's do an LED. Let's see. View selected footprint. This is what I wanted to do. Okay, and then measure tool. Say 2.54 bar. I just don't know. They don't have any. No, what? I don't want to use this. So let's. What's this? Rectangular. Don't try there. I'm not sure what I want. Little connector. Actually, let's actually make our own footprint just to give me some peace of mind. How was our symbol? Print editor. Make a custom one here? No. See if I can save it to the LEDs. Yeah, so you don't. Okay. File, new library. Global. Okay. Cody. Custom. Did I call the other one custom Cody or Cody custom? I don't know. Start changes. Where did I put mine? There it is. Save. Noodle. LED. V1. I'm just not sure how well it will work. Custom Cody. Okay. And we're just gonna quickly make this one too. I'm sorry for everybody who I just don't know how big I should make. And size corner. I'm more worried about the drill. There's that. Through hole one. And da 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 da. Ah, here. Hole shape round. That surely will be big enough. Oh, oops. Number one. Isn't it odd? Uh-oh. Zero, zero. Ah, there we go. Okay. Yeah. I think that's all we're gonna add for now. Mostly because I'm not entirely sure what it's gonna look like. So let's just go here to the footprint assignment. No, not footprint editor. No, 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 no. No, I don't need that. This one. Footprint assignment. Do the resistors. Yeah. Again, if anybody has any questions, always here to answer. No. Yeah. I think this is the longer one. Right? Selected footprint. That's fine. Use you, 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 you. Okay, and then U2 is this one here. It's our counter. So, I think I will use. There should be a dip libraries. Package dip. We need 16. You. I'm pretty sure These all should be 2.54. Let's look at our, get out of that. No, we need down to the bottom. It's usually where they keep it. Yep, 2.54, and then the space between them is 10.92 max, 6.6 is the actual package size. Let's go here. So 8, 7.62. That will be fine. Yeah, we'll just have to bend them a bit, which you usually do anyways. So I will use this one. Wonder what that means, brazed. Do it again. What does this mean? Yeah. Now, I only have to do the capacitors. Of which, we might as well go find the right ones. Digikey. These two I'll do surface mount ones. This one will probably be a through hole. Oh wait, yeah, we better save. What's on this card? Probably will tell me which one I need to use for through hole. I think it's a 0805 anyways, is usually what I use. It doesn't have a kit. Pretty sure it would be anyways for these ones. Faster SMD. And salt. Okay. This one. Do that. Now we need a aluminum electrolytic capacitors. So go there. That one. Active. In stock, normally stock, and exclude marketplace products. And let's just sort by the amount available. And we get this guy. KiCAD. Let's put 50 of them in the cart. $6, whatever. Okay. So now let's just look at how size dimension 5mm, height was 12.5. We want no capacitor T 5 millimeter. That's horizontal. We want a vertical. Where's our verticals? Radial it is. Pitch. Lead spacing 2. Lead spacing. So this guy. Now for the connector. Let's just see what we have for battery connectors. This. VR, yeah. That. Don't need that. Well, here, 3AA. See what it looks like. That would hold the 3AA. Let's just look at what, say, True Power PH 331P. PH 331P. It says it doesn't exist. PH dash. Nope. That's fine. If we just put in the connector, holy jeez. No, that's not what we want. 2x3, that's why. No, we don't need it that crazy. Let's just go with this one. Pin header. Yeah. And then I'll disconnect the batteries. I'll disconnect them manually by soldering for now. Okay. So let's save this. And let's switch to the PCB editor. I just want to make sure everything seems to be there. Update PCB, close. Okay. Oh, I just want to measure it. We're gonna have to shut it down here soon. Let's measure. Why does that keep on? Click there. Whatever. About 75, say. 35. So we're about 3 inches by 1.5 inches. I just want to know roughly how big this PCB will be. I don't think I'm gonna go any further now. Just save. There. X. I think it is in. I think this is in a get. Yeah. extract files, git add, git status. Maybe make a git ignore here. Okay. Just go nano. And we want git ignore. Ah! Relax. Star.jpg star.zip. Let's write that out. Now go get status. Git add dot git ignore. Oh yeah, piece. Let's just add the dot PDF now. Star dot PDF. Control O, Control X. How do I clear git? Clear stage git. Git reset. Git reset. Or git counter. Git add. Or here we'll do a git status. Git status. Git add. Or git commit. -m. Update. Git ignore. I'm sorry, this is also probably not what you were looking to see too. It's a demonstration on how to use get. Very boring, but it's very good to know how to use get, by the way. Git add with counter, git status. Yeah, I'll just git commit. I know that I should update my git ignore more, but I'm sorry, I'm not going to right now. Four bit. Counter. Okay. So now, I think that will be all for today. Thank you all for tuning in. If there's interest, let me know, and I will continue this stream and finish doing the PCB layout live. Otherwise, I'll probably just do it off camera. Anyways, thank you for tuning in, and I hope to see you next time.